Hello all. I hope you have already started your preparation. We have in IPCC, in CA IPCC, we have one subject, Enterprise Information Systems. So this particular enterprise information system is all about what is a software and how do we do. Okay, because uh, it is your responsibility being a chartered accountant to audit this particular information. Along with that, you are supposed to know what exactly is the information systems because you have to perform audit and also you are supposed to put controls on these particular information systems. So let me introduce myself. My name is Sandeep Kumar. I'm BTech in computer science engineering. I have 2 years of experience in software industry. After that, I changed my career path. So I am a qualified company secretary as well as I'm in graduation in law. Okay, so I work in one of the company, pharmaceutical company as an advocate. So this is my introduction. So let us start this particular enterprise information systems. Okay. So we have, as we already know, we have 5 chapters. Okay. So what are the 5 chapters we have? Let us see first. So paper 7A, enterprise information systems, we have 5 chapters. So chapter 1 is about automated business process. So in this particular chapter, we have two sectors actually. One is about what do you mean by business process and what do you mean by mapping systems. So these are the two things which we have in our syllabus. So we'll study about what is a process, what is a business process, what do you mean by business process management, and what do you mean by automated business processes. So these are the 4 topics. Along with that, okay, we have mapping systems, that is flowcharts and data flow diagrams. Okay, so these are topics that we have in chapter 1. When we go to chapter 2 is about more of financial and accounting systems. So, as I said, okay, being a chartered accountant, you are supposed to understand about an information systems. Not only understanding, okay, so you are supposed to put certain controls on these particular information systems, and also you are the one you have to audit these particular information systems. So that is the reason we have an exclusive chapter on financial systems, okay, where we'll be studying certain one of the basic and more foremost important information system, that is enterprise resource management. It is also called as an ERP. Okay, so what do you mean by ERP? ERP is nothing but an enterprise resource planning. Okay, so this particular software is used for the purpose of integrating all the information systems. Okay, so we'll study more about okay, what exactly is an ERP and how many modules it connects, okay, or it integrates together in the organization, and each and every module, like what exactly is an HRMS, what exactly is an okay, like SCM, supply chain management, customer relationship management, etc. All these particular modules are okay, will be integrated into ERP. So we'll be studying each and every module in this particular chapter. Okay, so it is more of practical oriented. So when we shift from like once you are qualified, once you go to a job, okay, there will be working on various information systems such as ERPs or Oracle Finance, etc. At that particular time, okay, you need to understand what exactly is that particular module and what are the different methods of audit we need to perform. So this chapter is more about ERPs. And chapter 3, which is very, very, very important, okay, not only for exams, okay, it is very important for our career also. Okay, so if you see, if at all you see this particular information systems, the very lengthy chapter, okay, is chapter 3. So chapter 3 is very, very lengthy because we have different types of information. I mean, not different types per se. We have we have to study different components of information systems, and also what are the latest technologies such as data warehousing, okay, artificial intelligence, etc. Along with that, okay, we'll be studying certain theoretical concepts of analytical languages as well. Further, we have a very, very huge topic of controls. Okay, so we have 3 types of controls, and what are different types of controls? All these particular controls are also there in this particular chapter 3. So when we study further, we'll start with chapter 3. We'll start with chapter 3 about information systems and its controls. Okay, so once you understand chapter 3, it becomes very easy to for you to understand chapter 4, chapter 5, chapter 2, and chapter 1, because the same controls will be reproduced in another form or in another format. Okay, so once you understand chapter 3 controls, it is very very easy for you to understand the rest of the chapter controls. Okay, if you take any chapter, okay, you will be having certain controls and you will be having certain risk analysis. So basically, okay, as per as my perspective, okay, so chapter 3 is a very very important chapter, not only for our examination, okay, because most of the case studies will be concentrated on these controls, okay, and not only for our examination, as I said, okay, it is also very 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 important for our career, because we have to audit this particular information system. So this understanding these controls is very very important. So after that, we'll be studying about chapter 4. Chapter 4 is more about e-commerce, m-commerce, and emerging technologies. So we'll study basically what exactly is e-commerce, what are different steps that we have in e-commerce, etc. That we study in this chapter. Along with that, we'll study about latest technologies such as virtualization, grid computing, cloud computing, mobile computing, etc. Okay, so these are the four important emerging technologies that we'll study in this particular chapter. And finally, we have chapter 5. Okay, we have chapter 5, that is core banking systems, which is a very, very, very important concept, because being an auditor, you are supposed to understand how exactly these information systems will work. Okay, so you go to any bank or you audit any banking sector, you are supposed to understand the systems, because we have completely, okay, converted our transactions from a manual transactions to an automated transactions. Okay, so if you go and withdraw certain amount, okay, if you want to withdraw certain amount directly, you'll go to an ATM machine, swipe the card, type the pin, get the money. It's simple. Okay, but okay, now how exactly we are able to automate this particular transactions using core banking systems? All banking system or all banking transactions will be automated using a software called as core banking system. So it's a very very important uh, chapter, okay, for us to understand. So earlier, if you see the old syllabus, okay, and a frequently asked question is, sir, how exactly this information technology? Earlier we used to call this subject as information technology. Earlier, people used to ask me, sir, how exactly this information technology will be helpful? Okay, so I used to tell them that, okay, it is just a basic understanding about an computers and all that things, but it is not so helpful in our careers. But thanks to ICI, so they have devised this particular, they have revamped this information technology and converted this information technology into enterprise information systems. Now, I can proudly say that, okay, what all you study, okay, you'll be practically implementing in your career, okay, once you are qualified. Okay, so once you have a qualification, what all these particular controls, risks, etc., will be implementing as an auditor. Okay, so that is the reason. Okay, if you ask me what is the percentage of relevancy, okay, now I'll tell like it's 100%. Okay, it's 100% very very relevant for our career. So that is the reason it's very very important for us to understand. But the only problem with this particular executive information systems is like it is like an alien subject for you. Okay, like computers, etc. It's a little bit complicated. So why I say complicated? Is it really complicated? I say complicated because you are reading this particular subject for the first time. That's the reason it's little bit complicated. But once you understand these particular subjects, believe me or not, okay, you will love this particular subject. Okay, so I'll I'll teach in such a way so that you'll understand each and every concept. Okay, so how exactly my presentation will be, or how exactly I will be teaching you. So every concept I'll be teaching by way of an diagram, a small diagram, which will help you in understanding this particular subject, as well as in order to understand more conceptually. Okay, so how exactly this particular control works, or how exactly this information system works, the same way I'll explain you. Okay, there will not be any stories, there will not be anything. You will be learning the entire real subject. Okay, in this particular enterprise information systems. Okay. So, without any delay, let us start this particular enterprise information systems. The only thing which you need to do is like read on day-to-day basis. Okay, first time you might not be getting this particular subject, or it will be little bit complicated to understand. But over a period of time, once you read twice or thrice, you'll definitely get a note of this particular subject. So let us start this particular chapter 3. Chapter 3. So let us start chapter 3. So what exactly is chapter 3? Okay, so chapter 3 is about information systems and its form. So chapter 3 is about information systems and its components. Okay. So now in this particular chapter, we have certain topics of information systems, and also we have certain topics of controls. Okay. So first we'll study about information systems. Okay. So basically, what is information system definition? Is information system definition. Okay. So we need to understand what exactly is an information system. Okay. So information system is nothing but, okay, it's nothing but a combination of, it's nothing but a combination of people, it's a combination of people, hardware, software, telecommunication networks, telecommunication networks, storage devices, and other resources, Okay. So what do you mean by information system? It's a combination of people, hardware, software, telecommunication networks, storage, and other resources. Now, what exactly this particular information system will do? These particular components, okay, will help to convert data into information, data into information. Okay. So why do we require an information system? It's nothing but a combination of people, hardware, software, telecommunication networks, storage devices, and other resources. So what exactly these information systems will do? These information systems will take this particular data and convert the data into information and convert the data into information. Okay. So basically, why do we require these information systems? Information systems are required for the purpose of conversion of data into information. Okay. So we need to understand what is data, what is information. Okay. So what do you mean by data? Data is nothing but raw facts. Okay. So wherever you see what is data, okay, if someone asks, okay, what do you mean by data? Data is nothing but raw facts. Okay. Raw facts is called as data. Now, what do you mean by information? Information is nothing but a processed data is called as information. Okay, what do you mean by information? Processed data. Processed data is called as information. So, why do we require information? Sorry, why do we require information systems? Information systems are required to convert the data into information. So what do you mean by data? Data is nothing but raw facts is called as data. What do you mean by information? Information is nothing but processed data is called as information. Okay, so this is a standard definition of an information system. Okay, so what are the combinations or what are the components we require? We require people, we require hardware, we require software, we require telecommunication networks, we require storage devices and other resources. Okay, so let us understand each and every component. Okay, so the basic idea we'll understand, we'll study each and every component in detail. Okay, in this particular subject, okay, nothing is left behind. Okay, we'll study every particular component in a very detailed fashion. Okay, so now who are people? People is nothing but a person who uses an information system is called as a people or a person. Now, for example, let us say I'm using a tally. Okay, so I need to enter the entries into the tally. So, who is a user? It's nothing but a person who uses that particular tally is called as an user. Okay, so second, hardware. Now, I want to use tally. Now, this particular tally is nothing but a software. The software has to be installed on a hardware. What do you mean by hardware? It can be your desktop, it can be a server, it can be any other computer device. On this particular hardware, this software will be installed. Now, third. So first component is people, second is hardware. Hardware is nothing but like computers, etc. It's nothing but a physical component of a computer. Okay, in simple language, it is nothing but a physical component of a computer which we can touch is called as a hardware. Okay, so like let us say if at all I take mouse, can I call mouse as a hardware? Yes, because I can touch it. Okay, it's a tangible thing. Okay, that is the reason it is called as an hardware device. Okay. Now, what is a software? Okay, software is intangible. Can you touch software? No, I cannot touch the software. Okay, so what exactly is a software? Okay, it consists of an electronic instructions. Okay, or I can call it as a software consists of certain programs. Okay, what is a program? What is an electronic instruction? We'll study. But just remember, what is a software? Software consists of certain programs which will make the hardware run. Okay, so what is a software? Software is nothing but it consists of set of programs which are required to make the hardware run. Just remember this particular thing we'll study. Okay. Next, telecommunication networks. What do you mean by telecommunication networks and why do we require these telecommunication networks? Telecommunication networks are required to transmit the data from one point to another point. Okay. So why do you require telecommunication networks? To transmit the data from one point to another point. Okay. A simple example. Okay. So if at all you take WhatsApp. Okay. If you take WhatsApp, so what exactly, how exactly that you are doing? Okay. If at all you want to send a message to your friend, hi, okay, on WhatsApp. Okay, so once you type hi and you say send, okay, but how exactly the data is transmitted from your device to your friend's device? Okay, so the data is transmitted using a telecommunication network. Okay, how the data will be transmitted, sir? Using a telecommunication network. Okay, now can you tell me which network your phone is using? Which network your phone is using? Now, can I say Vodafone, Idea? Okay, so these are subscribers. Okay, or I can call it I can call them as ISPs. What is ISP? Internet Service Provider. Okay, but actually, what exactly which network your WhatsApp is using? Okay, it is using internet. Okay, it is using internet. Okay, because of internet only the data is transmitted from your cell phone to your friend's cell phone. Okay, so what exactly is an internet? Internet is nothing but a telecommunication network. Okay, so what exactly that telecommunication network will do? It will transmit the data from one point to another point. Okay, so That is the reason we require telecommunication networks. Okay. Next is storage devices. So why do we require storage devices? Storage devices are required for the purpose of storing the data permanently. Okay. If you want to store the data permanently, okay, so you require the storage devices. Okay. So what are different types of storage devices, etc., that we'll study in detail. Okay, and other resources. Okay, so we may require certain communication devices and other resources as well. Okay, so what exactly these information systems will do? It converts the data into information. So we know what is data. Data is nothing but raw facts. What do you mean by information? Information is nothing but processed data is called as information. Okay, so this is a standard definition, okay, for information systems. Okay, so once you convert data into information, or the what is the big, okay, they can ask you what is the basic objective of information systems. Okay, the basic or primary objective of an information system is to convert operational data into information. Okay, so you may ask me, sir, what is data? Anything can be a data. Okay, so like let us say I have 10-year sales. Okay, I want to convert that 10-year sales into a pie diagram. Okay, so I take 10-year sales as data. I convert this particular 10-year sales into a pie diagram. Then what did I do? Okay, I converted data into information. So whatever you store on a computer, it becomes data. Okay, so how a computer stores the data, etc., that also we'll study. Okay. Sir, you may ask me, sir, why do we require information systems? What exactly is an information system? Okay. So these particular information systems, okay, are nothing but softwares. Okay. So majority or predominantly, okay, we can call it as a software. Even though we are using different components, but we call this particular we call this information systems as software itself. Okay. Again, which type of software? Okay, because we have two types. One is called as a system software, one is called as an application software. Okay, or system software is also called as an operating system, that also we'll study. Okay, so this type of information systems, okay, is called as an application software. Okay, you take any information system like Tally is an application software, ERP is an application software. Okay, so a software which is used by the user is called as an application software. We'll study that definition as well. Okay, so basically, okay, so if you ask me, so what do you mean by information systems? Okay, the answer is simple. Information systems are nothing but softwares. Okay, but why do we require softwares? Okay, to automate our work. Okay, so to automate our work. Okay, let us take a small example. Okay, so why do we require these information systems? Okay, so earlier, okay, how banks used to work, sir? Okay, banks used to work manually. Okay, so like in 1990s or in during 1995 till 1995, 92, 95 also, banks used to work manually. Okay, so what do you mean by working manually? It's nothing but like let us say if at all you want to withdraw money, okay, you need to go to bank. Okay, you have to fill in that withdrawal slip and you have to stand in a queue because those times, okay, the queues are very big. Okay, the queues are like it used to take like hours together to withdraw money. Okay, so you used to go to bank. Okay, you have to fill in the withdrawal slip. You have to stand in a queue. Okay, so once your turn comes, okay, what exactly teller will do? Teller is nothing but a clerk. Okay, so what exactly teller will do? Teller will say, okay, so he'll take that withdrawal slip and he'll check your account number. He open your book, okay, physical book. Okay, so he opens your book. He'll see whether you have sufficient amount. Okay, so if at all you have sufficient amount, he'll check first the signature. Okay, so if your signature is matching, then it is fine. Okay, if at all your signature is not matching, because we are not like Sania Mirza or Sachin Tendulkar. Okay, so daily we sign. Okay, we often sign. Okay, so if at all you are a qualified chartered accountant, that's a different aspect because daily you'll be signing. Okay, but people, okay, like me, okay, will not be signing daily. Okay, so okay, if the signature is not matching, so what they will do, they will throw that withdrawal slip on your face. Okay, and ask you to, okay, write again and come in line. Okay, so let us assume you stood in line for 1 hour. After 1 hour you got to know that your signature is wrong and you have to fill in again a withdrawal slip and stand in a queue for withdrawing such small amount. Also you need to, like, it used to take like 2 hours, 3 hours to withdraw the money. Okay, so this is how banks used to operate earlier. Now the present scenario. Okay, so if you see the present scenario, if you want to withdraw the money, okay, so you straightly go to an ATM machine, swipe the card, type the pin, get the money. It's as simple as that. Okay, hardly takes a one hardly takes 1 minute, okay, for to complete your transaction. Okay. So earlier, okay, we have a manual process. Now you have an automated process. How exactly we converted this manual process into an automated process using information systems? Okay. So using information systems, okay, we can convert a manual process to an automated process. Okay. So what is the first reasons? Okay, why do we require these information systems? What are two reasons? Okay, I can classify two reasons as: first one, for the purpose of automation. For the purpose of automation, okay, we require information system. Second one, for the purpose of what happens if at all you automate a particular manual process into an automated process. Okay, so your productivity increases. Your productivity increases. Okay, so like let us say earlier, okay, they used to manufacture anything using hands. Okay, now we have machines. Okay, so what is the difference between a manual labor and a machine? Okay, like let us assume, okay, a manual person can manufacture, or okay, they can do some sort of process. Okay, let us assume it takes 1 day to manufacture food. Okay, but if at all you use a plant and machinery, okay, using that 1 day we can, okay, produce 100 or 200 also. Okay, so always what happens if at all we have an automated system in place? Okay, we can increase the productivity. Okay, we can increase the productivity. And second, the chances of errors will be less. Okay, so what is the second reason why do we require information systems? Okay, the chances of errors is very very low. Okay, so that is the reason we require an information system. Okay, so this is a small introduction about information systems and a definition. So what is an information system? Information system is nothing but, okay, information systems are nothing but, okay, it consists of, or it's a combination of people, hardware, software, telecommunication networks, storage resources or storage devices and other resources which transform or convert, okay, data into information. So what is data? Also we understood what is data. Data is nothing but raw facts. What do you mean by information? Information is nothing but processed data is called as information. So this is about, okay, information systems, okay, a standard definition. Now let us understand the next topic. We'll understand about components of information systems. Okay, so we'll study what is the next concept, sir? Components of information systems. Okay, slowly we'll study components. Okay, so by now you understood what is an information system. It is nothing but a software which is required, okay, in layman language. Okay, what is an information system? It is nothing but a software which is required to convert data into information so that it will be used by a person to take a business decision. That's it, sir. Okay, there is no like a very difficult concept, nothing, sir. Okay, it's like, okay, a software, it converts data into information. That's it. Okay, so let us study these components. How many components we have in information systems? Okay, so first component is people. First component is people. Okay. Second component is about computer systems. Second component is about computer systems. Now these computer systems are further classified. I mean, okay, it's a combination of hardware and software. A combination of hardware and, so what is a computer system? I can call, okay, it's a combination of hardware and software. Okay. Third one is about data resources. Third one is about data resources. Third one is about data resources. And last one, study about network and communication. network and communicate network and communication system. So these are okay four components of information system. So what are the four components? People, computer system. Computer system is nothing but a combination of hardware and software. Third one, data resources. Fourth one, network and communication system. So these are four components of information systems. Okay, now we'll study one after other. Okay, so we'll study first one, people. Study about people. Okay, so who are people? As I said, okay, these people I can classify into two. I can classify people into two. Okay. So one, a person who uses an information system, a person who uses information system. Second one, a person who develops the information system, who develops information system. Okay. So if you see these particular people, first component of information systems is people. Okay. Who are people? People are nothing but a person who uses an information system is considered as people, okay, or a person who develops the information systems or develops the programs is also called as people. Okay, so people is defined in two ways. First one is user, second one is okay developer. Okay, so users can be an accounts manager. Like let us say if at all yeah, if at all we take tally, okay, like accounts manager is a user or auditor is a user. Okay, any person. He can be anything. Okay, any person can be a user, or any person who uses an information system can be a user. Next one, developers. Okay. Now in development, okay, we have certain other concepts also, like a person who writes a program. Okay. So generally, once you write a program, okay, so what happens? Okay, once you write a program, okay, it should be tested. Okay, it should be tested. Okay, so who will test it? Okay, we'll be having testers. Okay, we'll be testing these particular programs whether it is working as per the business requirement. Okay, so testers are also called as developers, and also the person who maintains the information systems. Okay, so the person who maintains, okay, like let us say once you develop the information system, you require another like requirement to develop. Okay, so that also comes under developing of this particular information systems. Okay, so who is a user or who are people? People are nothing but he can be a user or the person who develops an information system as user. Okay, a user can be an accounts manager, auditor, etc. Okay, if at all it's an accounting information system or if at all it's a financial information system. Okay, second, okay, even a developer is called as a user, a person who write a program, test a program, and also maintains a program. Okay, is also called as a user. Okay, so this is about the first component, that is user. Now we are studying components of information systems. Okay, so what is the first component? People. Sorry, what's the first component? People. Okay, so we are done with people. Now second, let us study the second component, which is very lengthy. Okay, we'll study this second component. Second component is about computer systems. Second component is about computer systems. Okay. So as I said, these computer systems are classified into how many types, sir? Or it's a combination of hardware. It's a combination of hardware and software. So we'll study in this particular computer system, which is the second component of information system. Okay, we'll study about hardware and software. Okay. So what do you mean by hardware? Okay, what do you mean by hardware? Now let us study. Now, in hardware, will understand what is a hardware. A hardware is nothing but any physical component of a computer. Okay? So, what do you mean by hardware? Nothing but physical component of a computer. Okay? So, what do you mean by physical components? Physical components is nothing but the things which we can touch is called as a physical component. Okay, so what do you mean by hardware component? Hardware component is nothing but the devices which we can touch is called as a hardware. Okay, so in this particular hardware, we'll study about four important hardware devices. Study about four important hardware devices. First one, we'll study about input devices. Study about input devices. Second, we'll study about processing devices. Third one, study about data storage devices. Data storage devices. Fourth one, we'll study about output devices. So these are the four hardware devices we'll study. So what are the four hardware devices we'll study, sir? We'll study about input devices. We'll study about processing devices. We'll study about data storage devices, and also we'll study about output devices. So these are the four devices which we study. Okay. So let us start with first one, input devices. Okay. So let us start with first one, input devices. Okay. So what is a hardware component, sir? So please listen and understand. Okay. So it's very very easy. Okay. It's not as very complicated thing. Very very easy. Okay. You need to understand that. Okay. So please have an open mind. Okay. Don't resist yourself. Okay. So I'm studying a different subject. No, sir. It's a very very easy subject. Okay, provided you understand. Okay, so if you understand, it becomes a very very easy subject. If you don't, okay, then it becomes a complicated subject. Okay, not only this EIS, any subject. Okay, if you won't like, or if you resist, okay, it becomes a very very difficult subject. Okay, but if you without resisting, okay, if you accept, okay, if you have an open mind, okay, to learn, then it is a very very easy subject. Okay, like for example, this particular computer system. Now let us assume that in the exam they gave a question. What do you mean by computer system? You can easily write it. Okay, like first point, computer system is a combination of hardware and software. Second point, okay, hardware is nothing but physical components of computer. Okay. Next point, okay, these hardware devices are further classified into four types. Okay, input devices, processing devices, data storage devices, and output. Okay? So this is how you need to frame your own sentences, but the words should be okay that from the material, because material words, okay, when I say material, study material, okay, or ICI prescribed study material words should come. Okay, and why it should come, okay, because those are the appropriate words in that particular context. Okay? That is the reason we are supposed to write that particular words. Okay, so it's just like a law. Okay, like in law you cannot write a different word. Okay, you are supposed to write the same word, because if you write a different word, the interpretation will change. Okay, the same way here also, you are supposed to write the same words. Okay, but how do you remember? You have to practice it. Okay, you have to practice repeatedly, then only you can remember. Okay, now let us come back to our hardware devices. So what do you mean by hardware? Hardware is nothing but any physical component. Okay, computer. How many types of hardware devices we have? We have four types of hardware devices: input devices, processing devices, data storage devices, and output devices. So these are four hardware resources. Okay, now let us study. Okay, first one, what is an input device? So input devices are nothing but these devices are required to interact with a computer. to interact with computer, we require input device. Okay, so like let us say, without keyboard, can you interact with a computer? Or without mouse, can you interact with a computer? A basic computer, I'm not saying again your phone where you have Siri and where you have other, okay, voice recognition commands you can use. But okay, I'm just saying about a normal computer. Okay, so without a mouse, like let us say I gave you a computer but I didn't give you, okay, mouse and keyboard. Can you do anything, sir? No, you cannot do anything. Okay, so why do we require this particular input devices? Input devices are required to okay, to interact with a computer. Now what are different types of input devices? Okay, you have different types of input devices, like mouse is an input device. So what's the first example, sir? Mouse is an input device. Okay, or second example, like joystick. Okay, so when you play a game, okay, you have this particular joystick. Okay, so joysticks are also called as an input devices. Or okay, certain types of light pens, like light pens. So this, okay, like this is pen. Okay, so this is also called as an input device. Because of this only I am able to write. Okay, it's a pen. Okay, so it's called as an input device. Okay, so light pen also are input devices. Okay, and also, okay, like what do you call, scanners. Okay, so barcode scanners are also called as an input device. Okay, so barcode scanners are input device. And we have other examples such as webcams. Webcams are also our input device. And can take a microphone. Okay, so if you take this microphone, okay, so microphone which I'm using is also an input. Okay, so why I'm writing these examples? Because they'll give you an MCQ saying that, okay, which of the following are called as input device? Option A, mouse. Option B, webcam. Option C, microphone. Option D, okay, none of them. Sorry, option D, okay, all of the above. Okay, so option is all of the above. So you are supposed to answer, because this all of the above and none of the above are it's very I mean danger. Okay, so you should be very careful. Unless and until you know certain examples, you cannot able to opt that particular all of the above and none of the above. Okay, so whenever you have an MCQ all of the above and none of the above, you should be very very careful. Okay, so what do you mean by input devices? Input devices are required to interact with the computer. So what are different examples of these particular input devices? Different examples for input devices are like mouse, joystick, light pens, barcode scanners. What do you mean by barcode scanners? Like let us say if you go to an what do you call, like a supermarket. Okay, so if you go to a supermarket and if you see these particular supermarkets, every item will have, okay, every goods will have a barcode on it. Okay, so they have an optical scanner. They swipe that particular optical scanner, automatically all the details of the product, okay, will be appear on the monitor. Okay, so that is called as a barcode scanner. Okay, so webcam is also an input device and microphone is also. So this is these are certain examples for input device. So what we are studying, sir? We are studying computer systems. Okay, okay, so what exactly is a computer system? It's the second component of information system. What is the first component? First component is people. What is the second component? Second component is computer systems. So how many types of computer systems, or what is a computer system? It's a combination of hardware and software. Okay, so what is a computer system, sir? It's nothing but a combination of hardware and software. Okay, so we started with hardware. So what do you mean by hardware? Any physical component of a computer is called as hardware. Okay, so what are different examples of hardware devices? Input devices is an hardware device. Processing device is an hardware device. Data storage device is an processing device. And sorry, data storage devices are hardware devices, and output devices are also called as and okay, hardware. Okay, so we completed the first one. Okay, first hardware device, that is input device. Okay, so we are done with first one. Now let us go to the second. What's the second one, sir? Second one is about processing devices. Okay, so what is the second one? Second one is processing device. This is very important for your exam. Okay, processing devices. Okay, so we'll study about processing devices. So what do you mean by processing devices? Okay, so why do we require these processing devices? Okay, so these processing devices are required for the purpose of, or it is used to process. You can call it as used to process. It's used to process, okay, data. Okay, so it is used to process data. For what purpose? Okay, so and how it will process? It uses certain programs to process the data or manipulate the data, calculate the data. Okay, it has a different okay, like sentences. Call it as manipulation. Call it as okay, like calculations, etc. Calculating data using certain programs. Okay. So what do you mean by processing device? It is nothing but process. What does it do? It processes data. What do you mean by process? Okay, we have an word called as processing. Okay, we have a word called as processing is nothing but to convert. Please remember this word. Processing is nothing but to convert data into information. Okay, so what do you mean by process? Processing is nothing but conversion of data into information. Okay, so it's a very important device. Okay, processing device. Okay, processing is nothing but it is used to process data. Okay, how does it do? It uses certain programs to process this particular data. Okay, it uses certain programs to process this particular data. Now, if you see, okay, so what exactly processing devices consists of? Okay, it's a combination of central process unit, a central processing unit plus okay, central processing unit plus motherboard plus sound. Okay. So what is motherboard etc. We'll study. Okay, what is sound card? Sound cards are required for the purpose of either recording the sounds or to show the sound. Okay, so what is the combination of processing device? Okay, so processing devices. First one is central processing unit. Second is motherboard. Third one is okay. Now let us study the first one, that is central processing. Little bit, we are going okay, into the depth of the subject. Okay, so first one we study about central processing. Now, this central processing unit is also called as okay, as what's a CPU. Okay. So, what do you mean by central processing unit? Central processing unit is also called as CPU. Okay. So, this CPU, okay, what exactly this particular hardware will do? Okay. Now, can I call it as a hardware? Yes, it's a hardware. Okay. What exactly this particular hardware will do? Okay, this hardware okay will process or execute an instruction, okay, or execute a program. Okay, so this CPU will execute programs. So what do you mean by central processing unit? Central processing unit is nothing but a hardware. So what exactly this software or sorry this hardware will do? It executes the programs. Okay, so what is a program? Programs are nothing but an electronic instruction. Okay, now it executes the program and also it controls different hardware. Control different hardware. Okay. So what is a central processing unit? Central processing unit is required. It's nothing but a hardware which executes programs and also control different hardware units. Okay. So okay, it is just like in human body. Okay, if at all you take a human body. Okay. So what is central processing unit for a human body? Okay, central processing unit for a human body is our brain. Okay. Now, if someone says, okay, like let us assume, I say, okay, stand up. Okay. Now, what exactly is stand up? I can call it as an instruction. Okay. Now, when I say stand up, okay, what happens through your ear? Okay, that instruction will go to your brain. Brain will, okay, work or execute that particular instruction, stand up. Okay. And when you hear a instruction stand up, what happens? An action will be performed. What is the action? Okay, your legs will start, okay, and you will stand up, okay. So that is called as execution. Okay, so what is execution? Okay, in order to perform an action, okay, giving an instruction, that means brain will give the instruction to the legs, okay, so that it will perform that particular action. Okay, the same way, even a central processing unit also executes certain programs or instructions, okay, in order to control the hardware. Okay, simple. In order to control different types of hardwares, we require this particular, okay, programs, okay, to control the hardware. Okay, like simple, okay, hardware, like again, if at all I take a human body, we have different components or different parts. Okay, now who will control all these particular parts? Okay, brain will control all the parts. The same way, in an hardware, who will control all the components or who will control different hardware units? It is the responsibility of central processing unit. For example, let us say you have a printer. Okay, so if at all you say control P, okay, so what is control P? It's nothing but an instruction. Okay, so who will receive that instruction? The instruction will be received by processor. Okay, so once a processor receives that particular instruction, okay, an action has to be performed. Okay, so this particular processor, once it receives control P, it executes that particular, okay, control P, and it will ask the printer to print the user documents. Okay, so what exactly it is doing? It is giving an instruction to the printer. Okay, printer is a different hardware. Okay, so printer, okay, will start working on printing that particular document. So what exactly a central processing unit will do? It executes the programs. When I say programs, it is nothing but, okay, set of electronic instructions, and also it controls different hardware units. Okay, it's a very, very important thing. Okay, now how exactly, okay, this particular central processing unit is manufactured? Okay, so this particular central processing unit, okay, so this central processing unit is manufactured using a material called as silicon. Okay, so we use what, sir? Use a material called as silicon. Okay, or we call it as, okay, small flakes of, okay, flake, F-L-A-K-E, okay, flakes of silicon. Okay, silicon is nothing but, okay, small, okay, material. So which material we use, sir? We use sand. Okay, when I say sand, okay, so we have so much sand. No, okay, can we call it as silicon? No. Okay, we need to purify this particular sand to the extent of 100%. Okay, the purification has to be done to the extent of 100%. Then only we call the sand as silicon. Okay, that is the reason, if at all you go to US, okay, you have a silicon valley. Okay, so because the main computing device is a processor. Okay, so how do we manufacture this processor? We manufacture this processor using a material called as silicon. So what do you mean by silicon? 100% pure sand is called as silicon. Okay. Now because it controls, it executes the programs and controls different hardware, we call this particular central processing unit also as brain of computer. We call this particular system, or we call a central processing unit as brain of a computer. Okay, so this brain of a computer is manufactured. That means, okay, we have certain millions of ICs. Okay, we have certain millions and billions of IC. What is IC? Integrated circuits. Okay. So even if you see our brain, we have a concept called as neuron. Okay. So what is a neuron? Neuron is nothing but a small portion of our brain where it retains the data. Okay. It's nothing but a small portion of our brain. It retains data. How many neurons we have in our brain? We have certain billions and millions of neurons. Okay, which will be combined together to form a brain. Okay. The same way, even a processor, or it is called as a central processing unit, is manufactured, okay, or it consists of certain billions and billions of integrated circuits. These integrated circuits are further manufactured using a material called as silicon. Okay, so what is silicon? Silicon we already know, it is nothing but 100% of pure sand is called as silicon. Okay, so this is about central processing unit. Why do we require central processing unit? To execute programs or to execute instructions. Second, okay, this particular central processing unit is required to control different hardware units. Okay, it can be a printer, it can be a, okay, it can be like a main memory, it can be any other, okay, hardware device which will be controlled by the central. Okay. Now, what is the material we use? We use a material called as silicon, which is nothing but 100% sand. Okay, and it is called as brain of a computer. And this particular brain or this particular processor consists of certain millions and millions of integrated circuits. Okay. So the question is whether a processor can understand, okay, our languages. When I say our language, Hindi, English, Tamil, okay, like Malayalam or Marathi, okay, or any other language. Can a computer understand our language? Okay, what exactly is the language which is understood by the processor? If you ask me, okay, computer cannot understand Hindi, Telugu, Tamil, Marathi, Malayalam, no. Okay, a computer or a CPU can understand only one language, that is called as a binary language. Okay, so it does not understand your language; it understands only one language called as binary language. Binary language. So, what do you mean by binary language? It is nothing but a combination of zeros and ones. Okay, it's nothing but a combination of zeros and ones. Okay, in like fifth or sixth class, we studied LCM. Remember? Okay, so how to convert a decimal, I mean, two-digit number to an binary number back to an, okay, digit. Okay, like let us say 10. Okay, so we used to do two. Okay, LCM. Okay, 5 0, okay, again 2, okay, 2 is 4 and 1, okay, again 2 1, okay. So if at all you want to know what is the binary for 10, okay, so we need to write like this, like 1 0 1 0, okay. So this is binary. So this is binary. A computer cannot understand 10. Okay, computer can understand only a combination of ones and zeros. Okay. Now, what all you store or what all you store on the computer, it has to be, okay, or any hardware device can understand only if you store in a binary format. Okay, now who will convert this, okay, like English to binary or Telugu to binary, etc.? That's a different aspect that covered, okay, that will be done by the operating systems generally. Okay, so this particular hardware, when I say central processing unit cannot understand any other language, Telugu, Tamil, no. Okay, it only speaks, okay, or it can understand only one language, that is called as a binary language. Okay, it understands only one language, that is called as a binary language. So what is a binary language? Any combination of zeros and ones is called as a binary language. How we converted this? Okay, even images will be converted into binary. Okay, letters will be converted into binary. Numbers will also will be converted into a combination of ones and zeros. Everything, okay, will be converted into binary format. Okay, so this is about, okay, central processing unit. Okay, so what is a central processing unit? Central processing unit is nothing but a hardware which executes a program which controls different hardware. Okay, what is the material we use? We use a material called as silicon. Okay, what is silicon? Silicon is nothing but 100% pure sand. Okay, it is also called as a brain of a computer. Okay, and this is, okay, this consists of, okay, millions and millions of ICs. What is IC? Integrated circuits. Okay, now whether this particular integrated circuits understand different languages, no, it can understand only one language, that is called as binary. Okay, so this is about, okay, introduction to central processing unit. Now we have different components in CPU. Now let us study what are different components of central processing. Okay. Now central processing unit consists of three components. Okay. So internally, how many components we have, sir? We have three components. First one is called as control unit. Second one is arithmetical logical unit. Okay. Arithmetical logical unit. Okay. And third one is registers. Third one is registers. Okay. So internally, central processing unit, how many components we have, sir? We have three components. First one is control unit, second one is arithmetical logical unit, third one is register. Okay. So we need to first we'll study this definition, and after that we'll take a small diagram and small instruction, and let us see how exactly this particular different components will work together to process the data. Okay. First we'll understand the basic definitions. Okay. So what is a control unit? Okay. Control unit. What is a control unit? This control unit controls flow of data and INST means instruction. Okay, so it controls flow of data and instruction to and from memory. Okay, so what is memory? Generally, we call it as main memory. Okay, what is to and from memory? Study. Okay, so control unit. What is a control unit? Control unit controls flow of data and instruction to and from memory. Okay. Second is arithmetical logical unit. Now, this arithmetical logical unit will perform arithmetical calculation, will perform arithmetic calculations. So, what do you mean by arithmetical calculations? Like this, yes, multiplication, division, etc. Okay. So, these are called as arithmetical calculation, plus minus multiplication and division. And also, it performs logical operations. And also, it performs logical operations. Okay. So what are logical operations like? Okay, and operation, or operation, or less than, equal to, greater than equal to. Okay, all these particular operations are called as, okay, logical operation. And third one is register. Okay, so these registers are further classified into four types. Okay, how many types of registers we have, sir? We have four types of registers. Okay, first one is called as accumulator. First one is accumulator. Second is memory register. Third one is data register. And fourth one is miscellaneous register. So how many types of registers we have, sir? We have four types of registers. First one is accumulator. Second is memory register. Third one is data register. And fourth one is miscellaneous register. Okay. So we have four types of registers. Okay. So what exactly accumulator will do? Accumulator will store a running value. Okay, so what exactly accumulator will do, sir? Accumulator will store a running value. Okay, so it stores running value. It stores a running value. What do you mean by running value? For example, I have 10, 20, 30, 40. What is an accumulated value for 10? 10. What is an accumulated value for 20? 30. What is an accumulated value for 30? 30 plus 30, 60. What is an accumulated value for 40? 60 plus 40, 100. Okay. So these are called as accumulated values. So it always stores an accumulated value. A very, very important concept, because we'll be studying flowcharts. Okay. At flowcharts, we are supposed to understand about this accumulator, because once you understand this accumulator, then only we can understand the flowcharts. A very, very important concept. Okay. So what do you mean by accumulator? Accumulator will store the running values. Okay, that is called as an accumulator. Next one, memory registers. Okay. Now memory registers are required for the purpose of storing memory address of an instruction. Okay, I can call it as simply address of an instruction. Okay, so address of an instruction. Like what is an instruction? Add is an instruction. Subtract is an instruction. Okay, division is an instruction. It stores the address of an instruction. What do you mean by address of an instruction? Simple, sir. Okay, like if I want to come to your house or to your home. Okay, so if you tell me the address, then only I can approach you. Okay, so the same way, every instruction will be stored on a memory. Okay, on the memory, or I can call it as every, okay, instruction will be stored on a particular memory register. Okay, every memory register will have an address. Okay, So if you give the address, then only the processor will execute that particular instruction. That is the reason it will store the address of an instruction. We'll study. Okay, so we'll take an example and we'll study how exactly this processing will be done. Okay. Now next one is data registers. So what exactly is a data register? Data registers are required to store the data. Simple. Okay, to store small amounts of data. Okay, to store small amounts of data, we require data registers. Okay. And last one, we have miscellaneous registers. Miscellaneous registers are required for the purpose of general purpose. They require for general purpose, and also we require this particular miscellaneous registers for like storing the results. Okay, it also stores the. So these are four types of registers. So we studied central processing unit, so which is nothing but a hardware component. Okay, so what is a central processing unit, sir? Central processing unit is nothing but a hardware component. What exactly it does? Okay, it executes the programs and it controls different hardware units. Okay, it uses a material called as silicon. What is silicon? It is nothing but 100% pure sand. Okay, it is also called as brain of a computer, and we require certain millions and millions of integrated circuits. Okay, so it understands only one language called as a binary language. Okay, what do you mean by binary language? Any combination of zeros and ones is called as a binary language. Okay. So how many functional units we have inside a central processing unit? We have three functional units. First one is called as control unit. Second is called as arithmetical logical unit. Third one is called as register. So what do you mean by control unit? Controls the flow of data and instruction to and from memory. That is called as a control unit. What is arithmetical logical unit? Okay, it is nothing but performing arithmetical calculations like plus, minus, multiplication, and division, and logical operations like less than, equal to, greater than, equal to, etc. Okay. And how many types of registers we have? We have four types of registers. First one is an accumulator. What exactly accumulator will do? Accumulator will store the accumulated value, or it stores a running value. What is the second one? Second one is nothing but a memory register. What exactly memory register will do? It stores the address of an instruction. Okay. What exactly data registers will do? Data register will store the data. And lastly, what exactly miscellaneous registers will do? Miscellaneous registers will store the result, or it is also used for general purpose. So these are four types of registers we have. Okay. So let us understand this particular components by way of a small diagram. Okay. So once we understand using a diagram, then we'll not have any further complications. Okay. So let us study. Okay, I hope you understood the theoretical part. Now let us study how exactly this will work. Okay. Now I'll take a small diagram. So let us say this as process. Let us assume this as is concentrate carefully. It's a very, very important concept. Okay. So let us assume this is a processor. Let us say this is main memory. What is main memory? We'll study. Okay. But for this example, I need this main memory as well. That's the reason I'm taking it. Okay, main memory. And third one, let us assume we have secondary memory. Okay. So introduce these particular memories. So memories are required to store the data. Okay. So memories are required to store the data. We have primary memory, or it is also called as main memory. It stores the data temporarily, whereas secondary memory stores the data permanently. Okay. This introduction is sufficient for you, okay, to understand this concept. Okay. Now, as I said, processor will be having how many functional units? It consists of three functional units. So if you divide this, okay, it consists of three functional units. First is called as control unit. Second is called as arithmetical logical unit. Third one is registers. Okay. Now these registers are also classified into four types. Okay. These registers are also classified into how many types? Are four types. Okay. So first is called as accumulator. Second is called as data registers. Remember, A means accumulator, D means data register. Third one is memory register. Fourth one is a general purpose. Okay. So how many types of registers we have? Four: accumulator, data register, memory register, and general purpose. Okay. So what is this particular part? This part is nothing but cache. What is cache register? Okay. What is cache register? Okay. So if you see, okay, a processor, how many functional units we have? One, two, and third is register. Okay, so these are three functional units of a processor. Now let us assume I want to execute a instruction. Okay, so every instruction, okay, first has to be stored into secondary memory. Okay, so add 10 comma 30. Okay, now the problem in the architecture is, okay, you take any computer, you take your cell phone, you take your laptop, you take your supercomputer also. Okay, a processor cannot access directly any instruction or data directly from secondary memory. That means a processor cannot go to the secondary memory and it cannot access the data. No, it cannot access the data. Then how exactly a processor should access the data? Okay, so the instruction has to load it. Okay, it has to be loaded into primary memory. And who does it? The operating system. Okay, will the operating systems, okay, will perform this particular thing. Okay, so it will load this particular instruction into main memory. Okay, so once it is loaded into main memory, whether a processor can access this particular instruction, yes, a processor can access it. Okay, now once it is loaded into main memory, what exactly control unit is? Okay, we studied. Okay, what is control unit? It controls flow of data and instruction to and from memory. What is memory? Main memory. Okay, here memory means always main memory, it is not secondary memory. Okay, so that means control unit will take this particular instruction to its, okay, location. Okay, can access data or instruction to and from memory. Okay, that means it takes this instruction, okay, and it places this instruction into its location. 10 comma 20, 10 comma. So that is called as, okay, first stage. Okay, first stage is done. Okay, now what is the second thing it will do? Okay, second it will, okay, taking the instruction from the main memory to the control unit is called as fetching. Okay, it is called as fetching. Just remember. Okay, so first phase is called as fetching. FEBCHING. As fetching. Okay, taking an instruction from main memory to control unit is called as fetching. So once fetching is completed, okay, it starts decoding. So what do you mean by decoding? Decoding is nothing but splitting the instruction and storing it into registers. Okay, so you have add. Can I call add as an instruction? Yes. Okay, so it should go to memory register. Add will store into memory register. And 1020. Okay, I can call it as data and it will be stored into data register. It will be stored into data registers. Okay. Now, as I said, memory registers always store the address of an instruction. Let us assume it is located on 3000. Okay. What is 3000? 3000 is nothing but address of this particular add instruction. Okay. Now, once this decoding is completed, okay, third stage will start. It is called as execute. Okay, it is called as execute. That means control unit will give, okay, a command or an instruction saying that ALU, you go to 3000 location and perform, okay, that particular or execute that particular instruction. ALU will go to 3000 location, okay, and it takes, what is the instruction? Add. Whether ALU can perform addition? Whether ALU can perform addition? Yes, it can do addition because we studied. Okay, ALU can perform arithmetical calculation. What are arithmetical calculation? Like addition, subtraction, multiplication, division, and it also performs logical operations like less than, equal to, greater than equal to. Okay, so it performs addition. That is called as execution. Now, once it is executed, last stage is called as storing. Okay, so what do you mean by storing? It performs that add 10 comma 20 means 30. 30 will be stored into a general purpose register. Okay, so this is how, okay, an instructions will be executed. Here a very important concept is the processor cannot access data directly from the secondary memory, and it should access the data, okay, only from primary memory, or it is also called as main memory. It is also called as main memory. Okay, so you need to remember this particular concept. Okay, this particular thing is very important. It's not there in your study material, but okay, I think this particular prerequisite is you require in order to understand the components of central processing unit. Okay, so what is the central processing unit? We are done with. Okay, so we completed central processing unit. Okay, now let us just revise what we have studied. Okay, so We studied about central processing unit. What is central processing unit? It's nothing but a hardware. What does it do? It executes programs and also it controls different hardware units. Okay. So what is the material we use? We use a material called as silicon. What is silicon? It is nothing but 100% pure sand. This particular processor is also called as brain of computer and it consists of billions and billions of integrated circuits. So what is the language it understands? It understands binary language called as, okay, or it's a combination of zeros and ones. Anything. Let it be a data, let it be video, let it be audio, let it be anything. Okay, let it be your photo. Okay, your photo also it will understand as zeros and ones. Okay, it will not understand in any other language. Okay, so the central processing unit, how many functional units we have? We have three functional units. First one is called as control unit. Second is arithmetical logical unit, and third one is registers. Okay. So what is a control unit? Control unit controls the flow of data and instruction, okay, to and from memory. Okay, what is arithmetical logical unit? Arithmetical, okay, or logical unit means, okay, it performs arithmetical calculations and also it performs logical operations. Okay, arithmetical calculations means plus minus multiplication and division, and logical operations are nothing but and or less than equal to, etc. Okay. Now, how many types of registers we have? There are four types of registers: accumulator, memory register, data register, and miscellaneous register. Okay, and miscellaneous registers. Accumulators are required to store the running value. Memory registers are required to store, okay, address of an instruction. Data registers are required to store the data, and miscellaneous registers are required for general purpose, or it stores the results. Okay, so this is about registers. Okay, so if you see, okay, we are studying, okay, components. Okay, so let us again revise, okay, what we have studied in today's class. Okay, so we started with information system and its component definition. What is an information system? It's a combination of people, hardware, software, telecommunication network, storage, and other resources. Okay, so why do you require information systems? So what's the basic objective of information system? It takes the data and converts the data into information. Okay, and what are two basic reasons for information systems? Information systems are required for purpose of automation or for the purpose of reducing the errors. How many components of information systems we have? We have four components. First one is people, second one is computer systems, third one is data resources, fourth one is network and community. Okay. So who are people? People can be a user or it can be a developer. Okay. So accounts manager, auditor, if at all they are using financial system or system. Okay, who are developers, the person who writes the program, tests the program, and maintains the program. So, what is the second component? So, first one we are done with people. Second component is computer systems. Computer systems is a combination of hardware and software. Okay. So, in hardware, okay, we started hardware first. So, hardware is nothing but it's a physical component. The component which you can touch is called as a physical component or hardware component. Okay. How many hardware components we have? Four: input devices, processing devices, data storage devices, and output devices. Okay. So input devices are required to interact with a computer. And what's the examples of these input devices? Mouse, joystick, light pen, barcode scanner, webcams, microphones, etc. And okay, this processing second is processing devices. These processing devices are required to process the data or manipulate the data or calculate the data using certain programs. Okay, so this okay, processing device is a combination of central processing unit, motherboard, and sound card. Okay, so what is a motherboard? Okay, motherboard is nothing but on the device. Okay, all these particular hardware components will be connected together. Okay, like let us say if at all you have a desktop. Okay, now in the desktop, okay, you have that dabba, right? Okay, the dabba is called as cabinet. Actually, it is not called as CPU. It is called as cabinet. Okay. Now, if you remove the screw and slide the lid, okay, inside you have a rectangular cardboard. It will be in a gray color. Okay. So, you have a rectangular cardboard. That rectangular cardboard is called as motherboard. Okay. So, on the motherboard, processor, main memory, and other components will be connected together. Because all the components are connected together, it is called as motherboard. Okay, that's it. There is no other reason to call it as a motherboard. Okay. So, third one is sound cards. Sound cards are required for the purpose of recording or to hear the sounds. Okay, so it consists of processing device is a combination of central processing unit, motherboards, and sound cards. Okay, so let us okay. We also studied central processing unit, which is the first component of processing device. Okay, so why do you require central processing unit? It is required for the purpose of executing programs and it also controls different hardware. So it is manufactured using a material called as silicon. It is also called as brain of a computer. It consists of millions and millions of integrated circuits, and it consists of binary. I mean, it understands only one language called as a binary language. What's the binary language? It's a combination of zeros and ones. Okay. So central processing unit is further divided into three: control unit, arithmetical logical unit, and register. Control unit controls the flow of data and instructions to and from memory. Arithmetical logical unit, okay, will perform arithmetical calculations and logical operations. Okay, registers, we have four types: accumulator, memory register, data registers, and decimal register. Okay. So please study up to here. Okay, we'll continue.